where you get the energy that you need. And when you're thinking about that, more than likely, you're probably thinking about food, something that you eat. What you eat gives you energy, and that's correct. Okay? But we have to think about where other organisms get their energy. Okay? So cows, where do cows get their energy? Okay? Well, if you think about it, cows eat grass. Grass is a plant. Okay? Where does the plant get its energy from? How does it make glucose? Okay? Hopefully you're thinking photosynthesis, the sun, things of that nature. The sun is the ultimate energy source when it comes to ecosystems. The sun has to be there. So if we look at this food chain that you see on your screen, energy flows through an ecosystem in a one-way stream, okay? One-way direction, like a one-way street. And if you recall the biogeochemical picture of the water wheel, the water was energy flowing in one direction, okay? And the wheel was the matter. The matter is what cycles. Energy flows, matter cycles. Hopefully we are remembering that food chains are a series of steps where we show the transfer of energy between organisms based on who is eating who. Something to keep in mind, and the thing that's usually messed up, is that the arrows that you see in a food chain are the direction that the energy moves. A lot of times the confusion comes from, they think that the arrow means who eats who, and that's not correct. Okay? We know that algae cannot eat a fish. Okay? The arrow represents the energy, the direction that the energy moves. So the energy that's stored in the algae moves into the flagfish once the flagfish eats the algae. So again, the arrows are the direction the energy moves. So energy moves through the food chain based on who eats who. From the game that you played the other day, you reviewed over decomposers, consumers, producers, primary producers, secondary consumers, everything of that nature. I do want to point out that decomposition, the role of a decomposer, is extremely important. The purpose of decomposition is to release nutrients that can into the soil so they can be used by primary producers. If we were missing decomposers, if decomposers were not a part of the ecosystem, ultimately that means that there would not be any nutrients to be released from decaying matter. There would not be enough nutrients to support their primary producers, ultimately causing the demise of the ecosystem. The ecosystem would crumble, it would crush. I really like this image. I got it from your textbook. It shows the decomposer and the primary producer, how they work together. So they use Lego bricks as an example. So if we have a Lego house that you see in the picture, if the decomposer breaks down the Lego house, it breaks it down into individual Lego pieces. And then the primary producer would take those individual pieces and turn that into something new. Okay? So I want you to think Circle of Life from The Lion King. When Mufasa is talking to Simba about how the antelope eats the grass, the lion eats the antelope. When the lion dies, the lion is returned back to the earth as soil for the grass that the antelope eat. Okay? Make that connection there. A food web is going to be much more complex than a food chain. A food web is going to technically be multiple food chains within one particular ecosystem. So the network of all the possible food chains within a given ecosystem. Even though this does look much more complex, it technically is considered to be oversimplified because there's almost a guarantee that we are leaving out organisms within that particular ecosystem. I would like for you to note that there are multiple arrows and that different organisms get energy from multiple different venues. They don't just rely on one particular organism to be their food source. And we have scavengers, decomposers, detritivore, omnivore, carnivore, herbivore, primary producer. A detritivore is kind of similar to a decomposer. A detritivore is going to be an actual organism that eats dead and decaying matter. Okay? The decomposer is what is breaking it down. The detritivore is what's eating it. With the complexity that comes with a food web, it is sometimes difficult to predict exactly how a food web or an ecosystem would respond under different environmental changes because there are so many different feeding avenues. And so like the alligator feeds on multiple different things. If one organism is taken out, it's kind of hard to determine what exactly would happen to that ecosystem if one organism was lost. And again, that has to do with the complexity and a safe fail within the ecosystem to keep the ecosystem strong. I wanted to show you this picture as well because I want you to keep in mind that it's not just land ecosystems, there are aquatic ecosystems as well. In this case, algae is our producer. Okay? The energy that's found in the algae moves into the krill, and then the krill feed multiple different organisms. Herring, anchovies, squid eat krill, the blue whale eats krill, the crab-eater seal, the Arctic petrel, which is a bird, and the Adelaide penguin all eat krill. So this is a large food source for this particular ecosystem. You need to be able to pull out particular food chains within a food web. So for example, a food chain found in this web would be algae to the krill, to the blue whale, to the killer whale. In this example, the killer whale is your apex predator. There is not a single organism listed in this particular food web that receives energy from the killer whale. So there's no natural predators here. And this one, this guy, killer whale, is your apex predator. You have this picture in the notes that I sent you. I drew the arrows for you in an attached document showing color coding the levels and where the energy is going. Again, just try to practice the direction that the energy flows. So the energy that's stored in the plants moves into primary consumer. Your primary consumers are usually 99% of the time always going to be herbivores. They're going to receive all of their energy from plant material. I'm not going to draw the arrows for you here just to keep the video short, but the arrows are on the attached document in a PDF. Onto the energy pyramids. We actually have 3 different types of ecological pyramids. There are 3. Pyramid of energy, pyramid of biomass, and pyramid of numbers. You need to know all 3, you need to know what they are, and be able to describe them. Most of the time, we're going to be referring to a pyramid of energy because it deals with the rule of 10%, and you need to be able to apply the rule of 10%. So each step in a food chain is considered to be what's called a trophic level. So in the pyramid, okay, each section is a step in the food chain. So the food chain, the first thing is the producers. Okay? In this particular example, they're leaving out the sun. The sun is your energy source, but the first trophic level would be the producer. Okay? Producers, then come primary consumers, secondary consumers, tertiary consumers, and then you can also have what's referred to as quaternary consumers. For our purposes, we will not go above quaternary, but there are more than quaternary levels. Producers don't have any subname in front of them. There's not like secondary producer or tertiary producer. It's all primary producers or producers. Consumers will have the subname, primary consumer, secondary consumer, and so on. But the first trophic level is always going to be a producer. Okay? So the ecological pyramid is going to show the relative amounts of energy or matter contained within the ecosystem. Okay? The energy is the pyramid of energy. Matter will deal with pyramids of biomass. Okay? If you look at this diagram, I also want you to notice that as you move up in the pyramid, the energy levels shrink, as well as the population size. There's a whole lot more producers and a whole lot more energy at the bottom of the ecological pyramid than there are at the top. You also have this diagram in the notes that I sent you. I do want to point out a couple of things here to explain the rule of 10%. So we have the 10% rule, okay, which basically is stating that only 10% of the available energy is passed on through each trophic level. And that's what these numbers over here to the side are representing. So if 1,000 kilograms is what is available at the producer level, only 10% of that 1,000 moves on to primary consumer. So 10% of 1,000 is 100, okay? And then it continues. Only 10% of that 100 moves on to secondary consumer, and so on. It's always 10% of what is available. So if only 10% is being passed on, what happens to this other 90%? Okay? We have to account for that other 90%. That 90% is lost. Okay? And it's lost as respiration, it's lost through heat, and it's lost through excretion. So releasing of liquids and solids from the organism. Okay? So 10% moves on, 90% of that is lost. Okay? And again, we'll talk a little bit more about it being lost in a moment. Even if we had a different number, so say this was 6,000. So there's 6,000 kilocalories available at the producer level. Only 10% of that moves on to the next level. So 10% of 6,000 would be 600. Okay. 600 kilocalories available at the primary consumer. Only 10% of this makes that 60. 10% of this makes that 6. Whatever the number is always 10%. Most of the time, for testing purposes, it'll be a nice round even number like this, so it shouldn't be too difficult. Every time you take a 0 off. The next slide is a image that may help that make a little bit more sense. Okay. So if we were using a liquid to simulate the food chain, okay? If the sun is the energy source, that's where the most amount of energy is coming from. If it's 100 liters, only 10% of that 100 liters moves on to the producer. Okay? 10% of 100 is 10 liters. Then 10% of this moves on to this, so on and so forth. So as we move through the food chain, the amount of energy diminishes. It gets smaller and smaller as you move up the food chain. This has to deal with energy loss. Okay, so energy transformation in living organisms. 100% of your energy comes from what you eat. Okay? Some of it is stored in your tissues. The rest of it is lost. It's lost through respiration. It's lost as heat, and it's lost as excretion. Okay? The majority of it is going to be lost as heat. You use energy to respire, and then energy to run your systems, excretion, the same. This last slide shows the differences in the different types of pyramids: pyramid of numbers, pyramid of biomass, and pyramid of energy. I'm going to focus on this first one because I feel like it's a little bit more simplistic and easier to follow. This first column. So you have the food chain, a nettle plant, a rabbit, and a fox. Okay. The pyramid of numbers compares the number of organisms at each trophic level. So for example, if that meant that there were 10 nettle plants, that's a really big box for that. And say maybe there are 3 rabbits and only 1 fox. Okay. So the bigger numbers on the bottom, next smallest, and the smallest at the top. That's what I mean by the actual amount of organisms. So like attendance, I count 10 nettle plants, I count 3 rabbits, and I count 1 fox. Pyramid of biomass is comparing a unit of measure of weight, how much mass, biological matter there is at each trophic level. And then energy, the amount of energy. So kilocalories, rule of 10%, that's what's going on here. There's more, in all cases, there are more producers than there are any other level within the ecosystem. Okay? So again, the trophic levels deal with the different levels in the food chain. They always start with a primary producer or a producer, either terminology is correct. Okay? So producer, primary consumer, secondary consumer, tertiary consumer, quaternary consumer. Okay? The sun is the energy source that fuels the entire ecosystem. It allows for all the food chains and food webs to occur. Okay? Rule of 10%, only 10% of the energy available moves on through each trophic level. The other 90% is lost. Hopefully that helps. And again, I apologize for the delay. Please reach out if you have any questions. Miss y'all, love you. Bye.